Hello everyone, I am Untitled. In this video, we will solve one problem in Chapter 7. Using a rope, an initially stationary 4 kg box is lowered vertically at a downward constant acceleration of 2 meters per second squared. When the block has fallen a distance of 3 meters, A. Find the work done by the rope's force on the block. Before solving the problem, let us draw the Freebody diagram of the object. We have only the forces, the gravitational force and the tensional force. And since the motion is downward, the constant acceleration and the displacement vector are drawn like this. Now we write the equation of motion by the help of the Newton's second law, F net equals ma. Since there is a motion only along the y-axis, in order to write the equation of motion along this vertical line, we choose the direction of the acceleration vector to be positive. Therefore, the net force becomes mg minus t, which is equal to m times a by the Newton's second law. Therefore, we get an expression for t as m times g minus a. We put the numerical values into this equation and obtain 31.2 newtons. The work done by the rope's force on the block becomes negative t times d, since the angle between the rope's force and the displacement d is 180 degrees. If we insert the corresponding numerical figures into this equation, we obtain negative 93.6 joules. B. Find the work done by the gravitational force on the block. Wg equals m times g dot d. Since the angle between the gravitational force and the distance vector is equal to 0, then we obtain m times g times d. Put the numerical values into this equation, then you obtain 117.6 joules, which is approximately 118 joules. C. Find the kinetic energy of the block. Here we utilize the kinetic energy work theorem, that is, delta K equals Q2 minus Q1 equals total work, where Q1 is the initial kinetic energy and Q2 is the final kinetic energy. Since the initial speed is 0, then the initial kinetic energy is 0. Therefore, the final kinetic energy is equal to the total work. Here, since the total work is the sum of the works done by each force, with the numerical values, we obtain the kinetic energy of the block when the block has fallen a distance of 3 meters as 24 joules. D. Find the speed of the block. Here we can use the formula for the final kinetic energy, K2 equals 1 over 2 times m times v squared. Then the expression for the final speed becomes, with the numerical values, we obtain 3.46 meters per second. Note that since this motion is an example of one-dimensional motion, we could use this formula to find the final speed. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.